Hello, hi everyone, welcome back to the channel. So today in this video lecture we'll be solving this problem, multiply two matrices. So this is one of the basic problems of 2D arrays or two-dimensional arrays, or we can call matrices. So in this problem we're given two matrices of dimensions n cross n both, where n is an integer, n into n are dimensions, where n first n represents the number of rows and the second n represents the number of columns. All we have to do is to multiply them and find a resultant matrix. So what will be the dimensions of the resultant matrix? Let's take a sample test case. So here we know we have these two matrices, matrix A and another matrix B, right? Now we have to multiply them and we have to return the result. We have to find the result, which is this one, right? Now here, notice that what we can do here is we can find the result, the resultant matrix, like this. We can find the resultant matrix by multiplying the, first of all we have to check whether we can multiply or not. We can multiply because we have 3 cross 3 dimensions of for the first matrix and the same dimensions for the second matrix, right? Now what do we have to do is to multiply them and find the resultant matrix, and that will give us our answer. So how we can do that? First of all, count the number of rows. The number of rows are 1 2 3. The number of columns are 3. So we can multiply every row with every column to find the result. So let's take the first row 1 1 1. Let's take the first column 1 1 1. So what do we have here? 1 1 1 1 1 1. So here we can see that 1 1 1, when we multiply the first row with the first column, why we can multiply? Because the number of columns, the number of elements in the first row are same as the number of elements in the first column, in the columns of in the first column. We can see 1 2 3 1 2 3. That means we can multiply them. That means the number of columns, or n cross n, the second dimension n, should be same as the first dimension of the second matrix B, right? Which is indeed the case because both of the matrices has same dimension. So let's continue the problem. We multiply the first element of this row with the first element of this column, which gives us 1 into 1 plus 1 into 1 plus, then we multiply the second element of the first row with the second element of the first column of the second matrix. That is going to give me 1 into 1, and finally we'll have 1 into 1 for the third element of the first row and the third element of the first column, right? So 1 into 1 here. So here this is going to give me the resultant answer, which is 3, right? The answer is 3. So here, let's see, let's do it. 3 is the answer for the first, and we can see we are multiplying the first row, which is the row number 0, with the first column, which is column number 0. So 0 0 is this position, 0 0 is this position, and we're gonna put 3 here. Okay, and now we multiply the first row with the second column, that is row number 0 and column number 1, right? Row number 0 with the column number 1, 1 1 1 1 1 1. So here we're gonna have 1 into 1 plus 1 into 1 plus 1 into 1, that is 3. So 0 1 here, then we'll have 1 1 1 1 1 1, 1 plus 1 plus 1, again first row with the third column, so that is going to give me 3. Again move to the second row, 1 1 1, start again from the first column till the third column, 1 1 1 1 1 1, multiply 1 with 1 1 with 1 1 with 1, add them, will have 3, right? Now we have 3 here. So we have 1 0, then again we have 1 1 1 1 1, then with this second column 1 1 1 will again have 3, 1 1 1 with the third column, which is 3 again, right? Now here 1 1 1 1 1 1, again with 1 1 1, which is the first column of the second matrix, so we'll have 3. And similarly this row multiply with the second column will give me 3, this row multiply with the third column will give me 3, right? And so on. So in this fashion we're gonna have this resultant matrix, which is my answer. And what I did is I simply took rows one by one, first row, then I multiplied this row with every column, then I took the second row, multiplied it with the every column, we took the third row and multiplied it with the with every column, and similarly we had our answer, right? So in this fashion we will going to proceed. Let's jump to the code implementation part. So here we have our coding example, and first let's calculate the size of the matrix A dot size, and let's create a resultant vector. Let's call it res n vector resultant 0. Let's multiply them. For that, let's iterate over every row of the first matrix. Now iterate over the every row of the every column of the second matrix, j less than n, j plus plus. Let's take the sum, which is 0. Let's iterate over the let's take the sum would be matrix A. So for the ith row we're going to take kth element, right? So like here, so I picked up the row number 1, I picked up the column number 1, and 1 1 1 1 1 1, right? That is going to give me 3. So first row, first column, and this first column and first row, right? So let's say, so the pointers are something like this. I is pointing to this row, j is pointing to this row. Okay, now I, j are pointing like this. K starts like this. K starts from 0 till n. So initially k is 0, and which element I am picking? Matrix A I K. Matrix I K. Matrix A I, which is 0, K is 0. So I am picking this element. So K is pointing to this. So I K, I am picking up this element, and I have to multiply this element with this element, which is the first element of the first column, and that is going to give me, again, that is going to give me 0 0. Fine, that is going to give me 0 0. So k is 0. So here row number would be k, right? Row number would be k, and in this fashion I will multiply this element with this. So 0 0 0 0. Then in the next iteration k will increment by 1. So k becomes 1 now, right? K becomes 1 now. K becomes 1 now. So then after that k becomes 1, and what will happen is I have to pick this element, which is the second element of the first row, and I have to pick the second element of the first column. Fine. So in this fashion what I will be having is I will be having the second element of the first row and second element of the first column, right? And in this fashion what we will have is we will multiply this element with this, and we have to add them. So k is 1, I is 0, so 0 1. So I'm going to pick 0 1, and from here I have to pick 1 0. I have to pick 1 0 because I'm pointing to row number 1 now. So k is 1. So now notice which element for the second matrix we have to multiply. We have to multiply this with matrix B K J, and in this fashion we'll have our sum stored, and after that I will store this sum into the desired location sum, right? And finally we are given here in this example that we have to copy the values of the output matrix into matrix A. So iterate over the matrix, first matrix, j0, j less than n, j plus plus, and store the result into matrix A. And like this we have to do it. Let's try to check for a test case, and here I have a compilation error because I vector of n, that's fine. What is the problem here? Vector of n, res vector, okay, here I should have n and not res, right? Okay, so let's submit it. Fine, so that's all for this video. I hope you liked it. Let's analyze the time complexity. So we can see that we have three loops, looped inside a loop inside a loop. So first loop, outer loop is running for n time, then n time, then n time. So it's going to give me n cube. So the answer for this is going to give me n cube, right? So what is the answer? Final answer, it's n cube. The time complexity is n cube. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel. I'll see you soon in my next video. Till then, take care. Bye bye.